We are looking at chapter number 9, which is mechanical properties of solids. A structural steel rod has a radius of 10 mm. So radius is given, the length is also given, 1 meter. 100 kilonewton force stretches it along its length. So there is a rod. And this is stretched along its length. We have to calculate the stress, the elongation, the strain. The Young modulus of this steel is given by 2 into 10 to the power 11 Newton per meter square. We assume that this rod is held by a clamp, say at one end. So the force which is applied at other end, which is parallel to this is the length, so it is parallel to the length of the rod. What will be the stress on the rod, which is stress is simply force upon area. Area is pi r square, this is the cross section area. So F by pi r square. Force is given, we can write 100, and then kilo, for that we write 10 to the power 3. Then the pi 3.14, r square, radius is also given, so we can convert it into meter and write here. That will come around this number. Then to find the elongation, we know that this delta L by L is given by, again, the stress, you can say F by A 1 by Y. Essentially Y is given by this number, F by A, and delta L by L, that is the linear elongation. So we will find out this delta L using this expression and put all these values. Force is known to us now. This force by A is given to us because we just found out this value. So we can directly put it here. And then we have L, which is 1 meter. Directly we can put it, and the Y is also given. So this comes to around 1.59 millimeter. And the strain, of course, is this one. So strain is given by delta L by L. Delta L is, we just found out, L is given as 1 meter. So this is around 0.16%, or this is the value. Okay. A copper wire of length 2.2 meters, so length is given, and a steel wire, so there is a copper wire and there is a steel wire of length 1.6 meter. This length is also given, both of diameter 3 millimeter. They are connected end to end. When they are connected end to end like this, this is C, this is S. When stretched by a load, they are stretched by a load, the net elongation is found to be this much, 0.70 millimeter. We have to find out the load being applied. So these two wires, they are under what? They are under tensile stress, because they have the same tension. Because the question, it is being said that they have equal load W and they have same area cross section A. So we have a expression, Young modulus is given by stress by strain. How to find out? We know all these values. This is given by W by A, and the strain is given by the stress, strain, and Young modulus. All we know, we will just put this value. Stress is W by A, Young modulus is YC, strain is delta LC by LC. This C is for copper, and same thing we have done for the stainless steel. So we can just equate these two. When we equate these two, we can get delta LC by delta LS. We'll take this and this on the one side, others on the right hand side, and we know the values. LC we know, LS we know, and from the table we can always find out the Young modulus of C and S. So we'll put this value and we find out this delta LC by delta LS as 2.5. Now what is the total elongation? Say delta LC for copper and say delta ls for steel. So just add them, we get the total value. When we solve the equation, because we have this equation, one equation is delta L by delta S is this one. The total elongation delta C by delta LS is given by 0.7. So we have two equations, we solve this, we get delta LC and delta LS separately. So this is 5 and this is 2. And of course with the value of 10 to the power minus 4 meter. And how about this? How to find this W? Because we know about these now. Any of these equation you can take. So let us take the copper one. Now we have to find this W, which can be taken from this expression we have already seen. Then we just have to put the area pi into r square. Radius we have to take this for this one. For copper one, YC is also known. Delta LC we have just found out. LC is also known. And we just put the value and we get W. That is the load being applied. In a human pyramid, this is a human pyramid. In a circus, the entire weight of the balanced group is supported by the legs of a performer who is lying on his back. See, this is the guy on the back. The combined mass of all the person performing the act and the tables, plagues, they are this one, this is 280 kg. The mass of performer lying on his back at the bottom of the pyramid is 60 kg. Each thigh bone, that is a femur, of this performer has a length of 50 centimeters. So it has 50 centimeter. And effective radius, this radius is around 2 centimeter. We have to determine the amount by which each thigh bone gets compressed under the extra load. So when this all load is on this thigh bone, what is the compression? So how we are going to do this? The total mass of all the performer tables and plagues is 280, mass of the performer is 60. So what is the mass supported by the legs of the performer at the bottom of the pyramid? We have to subtract these two. That is 280 minus 60, that is 220 kg. Now what is the weight of this supported mass? Because this is only 220 kg, we have to find out the 220 kg weight. Because the gravity is also working downwards. So 220 into 9.8 gives you 2156 Newton. And the weight supported by each thigh bone, because there are two thigh bones, so we have to divide it by 2. So we get 1078. The young modulus of young modulus Y of bone is 9.4 into 10 to the power 9 Newton per meter square. The length of each thigh bone is also given 0.5. The radius is also given 2. This is given in the question itself. So this is we have transformed into converted into meter, and 2 centimeter, let it be like that. We'll also change the this 2 centimeter because we need all in meters. So the cross-sectional area approximately of this thigh bone is given by pi. Then we'll use this radius. So it will be pi r square. And of course we know that the Young modulus is given by stress upon strain. Stress is F by A, strain is delta L by L. So delta L can be found out using F into L by Y into A. Put all these values because we have found out these values, and this will be around this number. And this is a very small change. The fractional decrease in the thigh bone can be obtained by delta L by L. So this is around 0.0091%. The average depth of Indian Ocean is about 3000 meter. We have to calculate the fractional compression delta V by V of water at the bottom of the ocean. Given that the bulk modulus of water is this much, we have to take G as 10. Now, the pressure which is exerted by this much or 3000 meter column of water on the bottom layer. So, water is all around. So, what is the fraction of this layer on this layer? This is given by pressure. We know this is rho hg. So, we'll use all these things, 300 meter, then the rho, this is height, this is rho, and this is the gravity. So, this comes to this number, and we know that the fractional compression delta V by V is given by delta V by V. Again, we have to use the bulk modulus. Bulk modulus is given by the value which is stressed by the delta V by V, that is stress by strain, and strain should be the bulk or change in the volume, the fractional change in the volume. So delta V by V can be found out using stress by V. Stress is of course this number, then V is given here, just divide them, you get 1.36 into 10 to the power minus 2 or 1.36%. Let us summarize. The stress is restoring force per unit area and strain is the fractional change in dimension. It can be delta L by L, it can be delta V by V. So there are three types of stresses: tensile strength, which is longitudinal stress, of course, which is associated with the stretching, or you are compressing, compression and stretching. We have shearing stress and hydraulic stress. For very small deformations, the stress is directly proportional to the strain. The stress is directly proportional to the strain of many materials. This is known as Hooke's law. The constant of proportionality, this proportionality can be changed, and we can put a constant here, which is the modulus of elasticity. So three elastic moduli we have: Young modulus, shear modulus and bulk modulus. These, they describe the elastic behavior of object as they are responding to the deformation force which are acting on them. And the solids which belong to a category or a class called elastomers, they do not obey Hooke's law. Then when an object is under, say, some tension or a compression, the Hooke's law can take form like this. We see this is very important for solving the problems. F by A is equal to Y delta L by L. This essentially has come from Y. Y is F by A by delta L by L. This delta L by L is the tensile or compressive strength, so you can say it as a strain. And F by A, the F is of course the force or magnitude of the force applied causing this strain. A is the cross-sectional area over which this force is applied, which has to be perpendicular to A. And Y is the Young modulus of the object. So the stress, this is the stress. So you can write it as stress. So this is stress by strain. This is very important. You just have to remember that Y is stress by strain. Other things will be solved. A pair of forces when applied parallel to upper and lower faces, the solid deforms so that the upper faces move sideways with respect to the lower. The horizontal displacement delta L of the upper face is perpendicular to the vertical height L, and this type of deformation is called shear. Means a body goes like this. This is a shear example. And corresponding stress is known as shearing stress. So this type of stress is possible only in solids. In this kind of deformation, the Hooke's law takes a form, but here we have to have this G, Y is replaced by G. G is shear modulus. The things remain same. This is force, this is area, this is change delta L, displacement of one object, end of the object in the direction of the force being applied. Original length is this. When an object undergoes the hydraulic compression due to stress exerted by the surrounding fluid will also exert some pressure. So Hooke's law takes form like this. P is the pressure, which is the hydraulic stress, which is given by capital B delta V by V. This P is the hydraulic stress on the object due to fluid. Delta V by V is the volume strain, and this is the fractional change in the object volume due to the pressure. And this B is the bulk modulus of the object. So this is the brief idea about the mechanical properties of solid. Thank you so much and take care of yourself.